So any configuration I do for the clocks or for the modes, nothing happens until I do a transition. And hardware can do it, usually if something bad happens, but as a user I have to do it in software. So I write to these configuration registers, and those registers maintain their values, but they don't take effect. I write to turn the oscillator on. Oscillator does not go on until I transition to that mode which turns it on. So I have to do a mode transition. And I do that by writing to a mode control register, and we'll look in the code on how to do that. And when the transition completes, there's a status bit. So application note 2865, there's a table of contents here of all these different examples. And each example is just focusing on one module. That's what I try to do, like one peripheral, like the PLL or the SPI or the A to D. Just consider these little Lego blocks that you will have to glue together for the application. And then on the third page, you'll see for Bolero here, for example, which this last column, which examples apply to these. So I want to look at, for Bolero, initializing the system clock. It's example 11, and right here. So on page 98, if I go there, let's just look at the kind of the boiler, the template used for these examples. First of all, just a little description. We're just going to set the system clock to 64 megahertz. That's what we want to do. And we're going to start with a crystal. We're going to go into the PLL and generate 64 megahertz. And then we'll select different clock sources, and we can look at it on a scope if we like. So to do that, these are the different output pins for Bolero. We are here. Uses port A0 for clock out. This is a little summary of the modes I'm using, and also a summary of the peripheral control registers for the clocks. We do need a clock to the SIU. Here's the PLL calculations. It's straightforward. I won't go into it. Some other features here, how long it takes the clock, a little note about the clock monitor unit. And then we get into these steps. And all of these examples have this table here, which is basically, this is the big step here, which is kind of analogous to a function call. And then what I want to do in there. And these should be your code comments. And then for this step, these are the appropriate bit fields in a register. And then here's the pseudocode. For example, the register in the mode entry module, I have run 0 mode configuration register, and here's the value to make this step happen. So these are the steps, and so it just gives you a roadmap where you are. And I'm just going to go on to the code for Bolero. First of all, this project is all the source and all the make files, even debugger script files, are complete on the CD. And we're going to start this shortly. But I wanted to walk through it first, and then I want everyone to plug in and make sure, we'll take time that make sure you can compile, download, step through code, and I'll walk through just the basics of the debugger. How do I change a register value? How do I go to a breakpoint? That kind of thing. Let's just look at this function first, because main does the function init modes and clock, and then initialize the output clock, and by the way, I turn off the watchdog. We'll talk about the watchdog later, but let's just look at these about 6 lines of code right here. Please pay attention. There's this register, the MER, that's basically I enable certain modes. If I try to run in a mode and it's not enabled, I'll get an exception. So I just specify which modes I'm going to use. I'm only using run 0. I also leave D mode, these others set. You can leave that as you like. If I'm using an 8 megahertz crystal, I want to go to 64. This is the value I calculated. If I had a 40 megahertz crystal, some parts use that. I'd use a different value. And now that I've written a value to the PLL, now it would be safe to turn it on. So I am going to use run mode 0, only run mode 0. And so I'm going to configure that to turn on the 16 megahertz internal reference clock, to turn on the crystal oscillator circuitry, and to turn on the PLL, and then use the PLL as the system clock. So that's done in this mode configuration register here. And then I'm going to have a general peripheral configuration here, peripheral configuration 1, that says, hey, any peripheral that uses this configuration will get a clock in run 0 mode. System clock will go to those peripherals using peripheral configuration 1 in run 0 mode. And in this case, I'm assigning this 1, which is the SIU, to be the peripheral configuration 1. That's the only one used here. Now I've done all my configuration. I mean, in 1, 2, 3, 4, 5 lines of code, I've done my configuration. Now I can transition to the mode to have those configurations take effect. So I write to this register twice, and the lower half word is what we call the key, and then the inverted key. The upper 4 bits specify the run mode, and run 0 is just value of 4 here. So I do that twice. Once I've done that, the hardware takes over, okay, and a transition takes effect. And during this transition, we do it all for you. We do 2 things. Number 1, we activate, you know, hey, the oscillator is, yes, it's still on, keep that on, and the crystal is on, and there's a default timeout for the crystal. You can change that, but we wait for that timeout to occur, and then we wait for the PLL to lock on top of that, after that. So we will not complete that transition until the PLL locks. And I just got a call yesterday. Steve, my PLL, or my mode transition never completes because there's a mode transition status bit here I look at. Is it done? Is it done? Is it done? And I just wait forever here in this simple example. And he never gets done. He says, well, take a look. Maybe your PLL isn't locking because you gave it the wrong values. And maybe you didn't have an 8 megahertz crystal, you had a 40 megahertz crystal. That happens to me all the time. Like, oh, doggone it. Who put 40 megahertz on that board, you know, kind of thing. So that's one reason why you won't. And, you know, exit a mode transition. So we wait there, and then it's always good practice to say, okay, now I finished my mode transition, but am I in the mode that I want it to be? Because let's say John happened to be visiting your school and he took the crystal off the board. Maybe you went into a safe mode instead. So you want to make sure, am I in the run mode? Now you know where you're at. So I think this code you can replicate, but as you add peripherals, you're going to add more lines of code, and you'll see that in the examples. This is just for the SIU here, but you will add more lines of code, and then you're done. Now you have your PLL configured 64 megahertz, and your peripherals are getting a clock. Okay, now's time for you to play. And first of all, everyone's got this compiled. So in your Code Warrior directory, and you know the default is program files, Freescale, and then Code Warrior for MPC 55XX and MPC 56XX 2.7. There's a folder, Code Warrior examples. And there's a folder in there that 560XB-CW. So in that folder is the examples that we're gonna play with the last one, PLL 6 clock. Go to that folder, double click on MCP, and Code Warrior should start. Okay? And while that's starting up, you can connect your USB to the board, which will power the board. And very briefly, you can expand sources here and then double click on main C and see the main code, and you can edit it. But you have to do 2 things. One, you have to make the project, so you go to Project, Make, or you can click on the Make icon right here. So you click on that, and it will compile. And then the second thing you do, I want you to debug. So you can go to Project, Debug, or click on the debug icon right here. And then you will bring up the debugger, and it will, originally you might get a connect message, and in this case it's going to program, it'll either download to flash or to RAM depending on the target. So I want you to get there, and I want everyone to try that now. Make sure, we'll take a little break here. I'm going to walk around and make sure everyone's working.